Electric vehicles are taking over the automobile market. When electric vehicles first showed up in the automobile market, they were small, clunky, and slow. But advancement in technology has brought about an improvement in EVs. Car makers producing combustion engines are considering EV lineups so they wouldn't miss out and be left behind in the competition. Battery technology has improved since the debut of the first electric car, and now we have electric cars and plug-in hybrids that can outperform combustion engines and promise lower maintenance costs and deliver better efficiency. Right now, electric cars are limited by their range in remote areas where a charging station is not present. It could be quite a dilemma, so this brings us to the invention of a revolutionizing tech: wireless charging roads. Michael Faraday is regarded as the father of electricity, but Nikola Tesla's approach is very fascinating. When Nikola developed electricity, he never imagined that we would have power lines crisscrossing the world. At an interview in 1926 with the magazine Collier's, he mentioned that all railroads will be electrified. The most valuable application of wireless energy will be to the propulsion of flying machines. Nikola had a glimpse of the truth because he was, half right. Cell phone networks use wireless networks, railroads are electrified, and we just might have wireless charging roads in a few years. Now, this discovery might amaze you, but it is possible that electric cars would not need to plug in for charging purposes anymore. A trial for this tech was announced in Nottingham, and the government of England earmarked £40 million for the development of the technology. Automotive companies like BMW already employ static wireless charging using pads that can replenish your car's batteries when you are parked over them. Electric vehicles are now widespread. In Norway, sales from electric cars went up 54% in the market share in 2020. The sale of electric cars took over that of diesel, petrol, and hybrid cars. But in this part of the world, the German automaker Volkswagen dominates the EV market, not Tesla. About a decade ago, electronic vehicles only made up 1% of all cars on the road. All of these numbers brought about investigations into how EVs get charged and brought this innovative tech to life. How do wireless charging roads work? Researchers are thinking forward into the future, looking when all the cars we have on the road will be battery operated and require constant recharging. Researchers from Stanford and King Abdullah University of Science and Technology are all working towards solving the same problem. At some point in the near future, when all we have on the roads are electric vehicles, the number of charging stations available might not cater to all the cars we have on the road. To have a wireless charging road, a lot of things have to be considered. The process is based on inductive charging. A wireless charging road is created by placing efficient dynamic charging systems, magnetic coils, under the road. These systems would be capable of power transfer to stationary or moving vehicles. Think of the way wireless charging for mobiles works, but on a larger scale. For the transfer of energy to begin, the car has to be in proximity to the charging coil. As simple as that concept sounds, many things have to be thought about, and calculations involving statistical geometry have to be carried out. Wireless charging roads will greatly influence the next generation EVs and would help manufacturers determine what size of battery needs to be in an EV to make it more reliable than a combustion engine vehicle. For these wireless charging roads to be implemented, calculations have to be carried out. The presence of wireless charging roads will affect how an e-driver will commute. It would determine what route he takes to get him to his destination, and we cannot assume that everyone would make the switch to EVs overnight. So he has to share that same road with diesel, petrol, or hybrid-powered cars, which would affect traffic control. Now, many factors need to be considered when implementing this technology. Traffic control being one of them, urban planning is another. The density of wireless charging roads in any location also has to be considered. The time drivers will have to spend on the road to get a decent charge also needs to be taken into account. Calculating all of these parameters are important because they would influence the deployment of the technology. It would even determine how soon people in different regions of the world would get to utilize the tech. Challenges. Electromagnetic energy can carry and transfer data. It can also do the same with energy. Now, you might be wondering, if we knew this all the while, why do we need to plug in electric devices? Well, that is because there are practical challenges that face the use of electromagnetic waves to transfer energy. Over short distances, wireless charging is more practical. It takes wireless charging phones, for example, but over a long distance or moving objects like cars, in the case of wireless charging roads, it is more complex. These require beams to be focused on a receiver in the object you want to charge. There is a technique that was demonstrated by a team of MIT researchers in 2007. Improving ideas pioneered by Tesla demonstrated how a magnetic coil can drive electric current in a device attached to a partner coil. This is possible because if a magnetic field vibrates at a special frequency, it can make a nearby magnetic field wobble in response. This group of researchers started a company in Watertown, Massachusetts. They improved on it and have had their tech implemented into a laptop and some electric vehicles. The problem with this technique is that the connection between the two coils is very delicate. If you move the transmitter or receiver just a little, the whole system disconnects. So how would this work for wireless charging roads? Well, until the tech is improved upon, we aren't at a stage where it can be adapted to wireless charging roads. However, in 2017 and 2018, two groups, one headed by Yoon Ra-dee and the other at Stanford University, have independently come to create workarounds for this technique. Using a theoretical concept gleaned from optics, they made both the receiver and transmitter work together as one entity. When one side moves and changes the vibration frequency, the other responds and compensates for the change. The inclusion of this flexibility in the system allowed them to exploit physical laws and find out which frequency would be best suited for the system without a need for software or manual adjustment. And it worked, but they were losing about 90% of the energy that they were trying to transfer. Now, according to a research paper published in Nature Electronics, the researchers at Stanford University have managed to solve that problem of power loss and created a system that can transmit 10 watts over 2 feet with 92% efficiency. They got the system to perform well at even closer distances. The coils are 2 feet wide and will still be able to transfer power even if they're moving at a speed of 200 miles per hour. This technology can be applied to wireless road charging technology, but it would take a while before it gets into commercial production. Now, we don't know what long-term exposure to magnetic fields might do to the human body. Health safety needs to be considered, and this could put a stop to the development if it is found to be negative. Although the tech is not up for implementation yet, the cost of building the facilities to accommodate it and maintain it has to be put into consideration. EV users should expect to pay more tolls on such roads if it is finally implemented, and if all of these challenges can be overcome, wireless charging roads might be closer to implementation than we think. In conclusion, wireless charging can facilitate the implementation of fully autonomous vehicles on our roads. It would also mean that in the nearest future, there wouldn't be a need for charging stations. EV manufacturers can take their attention off of inventing super battery packs that are long-lasting to increase the range of the average EV. We can go about in our EVs without even thinking about charging them. This approach is more user-friendly and it will go a long way to affect road transportation as we know it positively.